Welcome back to the Automation Podcast, the world's number one industrial automation product and technology show. Thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience, and thank you for tuning back in this week. Now, for those who may be new to the show, my name is Shawn of Insights in Automation, and each week I invite a new vendor to come on the show to tell us about their products and technologies. And during their presentation, I play the role of the audience, asking questions I think you have and questions I have as well. Now, given that a quarter of our audience listens to the show, doesn't watch it, I will also try to call attention to any details in the visuals that I think the listen only audience may want to know about. So, with that said, I want to welcome first time on the show, Sumit from Emerson, who's going to talk to us about Emerson Discrete Automation. And Sumit, before you jump into your presentation, since this is your first time on the show, could you just take a moment and introduce yourself to our audience?
Sure, Sean. Thanks a lot for inviting me on the show. It's a really great opportunity for us to forecast what we are doing in the automation world. So my name is Sumit Kapde. I am responsible for the global business development of factory automation segment, which is within the Emerson's Discrete Automation Group. So we help our customers design the solutions specific for their applications, and with that solutions, they can reduce their total cost of ownership with the solutions that we implement. And today we are going to talk about exactly achieving these key points, mainly focused on the paint automation topic.
But before we jump in, I want to thank theautomationschool.com for sponsoring this episode of the show. That's where you'll find all of my online courses on Allen Bradley and Siemens, PLCs, and HMIs. So if you know anybody who needs to get up to speed on those products, please mention theautomationschool.com to them. And now let's jump back into the show.
So basically, just to introduce Emerson's Discrete Automation Group, at a glance, we are operating worldwide with this core portfolio, which includes our leading brands like ASCO, Aventix, Descom, TopWorks. And additionally, we have also a couple of brands which are from the acquisitions coming on, mainly focusing on PLC systems, software solutions from PAC Systems and Movicon. But also we have a power supply brand called Solar HD, as well as a welding machines brand called Branson. With all this consolidated portfolio of leading brands in the industry, our goal is to drive the efficiency for our end customers, where we help them increase the productivity, reduce the energy usage, be it with compressed air or gas or electricity. Our components are exactly designed to reduce this consumption. And of course, with the data monitoring and acquisitions, we help our customers enable the insights of what's going on in their machines and unlocking those usage of the trapped data where, the customers really need to make sense of those data.
I want to jump in for a second. I just noticed a couple of your leading brands that audience may also know. I know we cover Advantix a lot on the morning show. And I also see you have Appleton and then OZ Gedney?
Yeah, correct.
And so those are other brands that you guys may recognize in addition to PAC Systems and TopWorks and ASCO. So I just wanted to throw that out there for the audio audience. And let me turn it right back to you.
Absolutely. Thanks a lot. Yeah, Appleton also for industrial lightings and so on, very important part of our discrete automation group. And with all these consolidated brands, Emerson's current focus, or let's say the main motto is floor to cloud. That means we want to offer solutions that are comprising of floor level devices, control systems, edge devices, which can transfer the data from those machine components to the software, and also, of course, the software layer plus the cloud level. So all the automation pyramid hierarchy can be optimized by Emerson's components and solutions. If we do a little bit of, let's say, a brief introduction to the main brands that we focus on when it comes to display automation, we obviously start with Aventix, which is the main brand for factory automation components, where we offer our customers solutions with electric linear motion, pneumatic systems, control systems, sensors, position, feedback, and so on, feeding and handling systems from our recently acquired brand of Afag. Then comes ASCO and TopWorks, which is mainly for industrial automation, where we offer solenoid and air operated valves, very legendary brand into industrial automation systems, switches and sensors, pulse valves, which is, let's say, more than 70% of the market is with ASCO's pulse jet valves, and also industrial burner controls. So these two are mainly, let's say, going into factory automation landscape. Then we have TESCOM, which is precision fluid control, where you need to regulate the flow of gases or any other form of media, where the pressure is, let's say, more than 40, 50 bar, or even up to 400 and 600 bars. So these are very, very high pressure fluid control components. Then we have Sola HD Pack Systems and Movicon for controls and software part, where we also offer SCADA systems, HMIs, PLCs, analytics software, and power conditioning modules. For welding and assembly, we have Branson for plastic and metal welding. Of course, we're currently in the battery market. They are also looking for very much precise cleaning tools and those welding machines that are catered to battery modules applications. So that's where also Branson keeps their customers' problems solved with their machines.
But before we get into that, I wanted to thank those of you who signed up in our new membership program, either on YouTube or at theautomationblog.com. In appreciation of your support, you get exclusive access to the videos of episodes that are not sponsored by the vendor. Now, to learn more about our membership program, which is only $10 a month, please visit theautomationblog.com/memberships. And with that, let's go ahead and jump back into this week's episode.
Currently, as I told, so our concept right now from Emerson is providing floor to cloud solutions, where you can see that a lot of components go into the factory floor, being from machine control, fluid and motion control, intelligent sensing, materials joining, visualization, and so on. All these components can transfer some sort of data. That means these components are making those machines smarter. And we want to use the data from these machines to transfer to edge devices, which can interpret the data on how they can be used and transferring it to the cloud to, let's say, have access factory-wide, or even if you have more than one factories in multiple locations, then you can have a central headquarters tapping into those data from all the factories. So that makes, let's say, the solutions more scalable and open automation for those factories which have multiple plants, and that enables them to make more, let's say, fluent decision making when it comes to their production floors. And how do we make that? So we have instruments and sensors for compressed air, for gases, for liquids. We have a lot of position control valves, valve systems, feeding and handling systems with motion drives, even the welding and assembly systems. All these are intelligent software-enabled devices. We transfer the data to control systems. We have our own range of edge device, PLC systems, SCADA, HMI software, and also power supply, which can gather this data and then put it in software. So what we did is we have a standard stack of software, let's say, for compressed air monitoring. So this stack of software can be used by n number of customers. We don't have to, let's say, specify it for customer A and then do it for customer B. This can be just used as a plug and play software solution. And with this, we are solving main customer pain points like maximizing the performance of the existing machines. A lot of industries are, let's say, having a lot of problems with the throughput and the output of the machines, and they want to increase it rather than investing in a whole new line of machines. So we help them maximize the performance of these existing machines, increasing the efficiency of those equipments. That means we are increasing also the lifetime of the machines with having those components installed, and that can give us more data on when are those components going to fail and when they need the replacements of those components.
So you have this slide I think is excellent. It really explains a lot to me. So everything from the instruments and sensors on the very
Yeah,
bottom, the valve
correct.
stacks and all that, going up
Yeah,
to the industrial computers, edge devices, PLCs, PACs, the power supplies,
yeah,
including HMIs and SCADA. And then above that, we have these tailored solutions. And the one that kind of drew my eye was the clean in place because everybody's,
mm,
a lot of systems have to have that clean in place, whether it's
yeah,
food and bev or life sciences. And so just having that as a bolt on, he has a software solution that's tested and works. In addition to air
correct.
compressed monitoring and the other ones you show up there, I think that's pretty impressive. And like I'm already learning, like I know so much more about your product line now than I did at the beginning here. So let me turn it back to you.
Absolutely. Thanks a lot. Yeah, I mean, Emerson is a big world, right? So it's
Hmm.
always a little bit, even for us, it's a bit confusing when it comes to so many product portfolio on, let's say, how to put it all together. But we have engineers who work exactly for these kind of solutions, and they know what we can collaborate with our sister brands from other Emerson divisions, like, let's say, Rosemount, which has a wide range of sensor capabilities, and how we can integrate it into the discrete automation portfolio, right? So that's what the beauty of Emerson is, that we can offer, let's say, the whole factory-wide automation solutions, and we can let's say maximize the customers' purchasing and procurement timeline. So that's where what we have to offer here. Now let's jump into the solutions for paint automation for with robotics. That's what the topic for today's is. And mainly what we did do is that we identify what are the challenges in the application. Whenever we have a customer who comes to us and says, I want your automation components, we don't start by discussing catalog products or anything. We ask them, what is your problem exactly? What do you want to achieve when you talk about automation components? So to give an example, with the paint application, we have a lot of customers where we gather the data of what are the standard challenges, and we drill down to four main challenges. The first and the foremost, and also the most important one, is the overspray. So whenever you have a high pressure jet and a compressed air of 6 bar, 7 bar is flowing through it, along with the paint media, that means it is bound to overspray up to some extent. And because also there are a lot of changes in the pressure during robotic painting application, be it on cars, trucks, buses, or airplanes, there is going to be a lot of flow and pressure changes during those operations, and that makes a lot of overspray into the system. So that means if you apply 100 liters of paint through the robotic systems, those 100 liter of paint is not going to stick to the body of the car, trucks, or buses. It's bound to have some sort of losses, and that loss is around 20 to 25% in the industries. So these are a major challenge. And if overspray is a challenge, the second one is the paint sludge. So whenever there is an overspray, the paint particles are in the air. After your, let's say, daily operations, all those paint particles are going to settle down on the floor. And when those particles are on the floor, they will create a waste material called paint sludge. And most of the industries or most of the geographical countries, they are not allowed to dispose this paint sludge into a landfill or anything. So you have to treat the paint sludge, which costs a lot of money. And the third point is the process optimization. That means they have to optimize the process. That means they have to have those movements of the robot so precise that they reduce the amount of time it takes to paint one body, be it cars, trucks, or buses, and also reduce the, let's say, all those paint sludge and overspray characteristics with optimizing those processes. And that brings me to the fourth point, which is the minimize of the media consumption. That means they want to reduce the consumption of raw material of paint as much as possible, because it costs a lot of money. Be it when you are spraying on a Ford or a BMW or Mercedes, 1 liter of paint costs a lot of money. So all these four challenges are known to us as Emerson, and whenever we talk to customers about paint, we know that these are the challenges and how we can solve them as a company.
Hey everyone, I just wanted to jump in here and pay some bills. Thank you, first of all, for listening to this episode. And while today's vendor wasn't able to sponsor this episode, I still wanted to invest the time to bring it to you because I think you're like me. You like to learn about new products and technologies. So, with all that said, I'd like to ask you to consider becoming a member for just $10 a month, either on YouTube or at theautomationblog.com, to help me offset the cost of producing these episodes each week. In exchange for your membership, you will receive member-only perks, including access to my daily news show and ad-free editions of every unsponsored episode of this show. With that said, thanks again for tuning in this week, and now we'll return you to this week's episode.
But we, of course, try to put those into numbers. That means we do a cost-effect analysis on all those key challenges, and in this case, about the waste generation due to the overspray. So if you see on the left-hand side, we identified that approximately 20 to 30% of the paint is being lost due to overspray. That means the efficiency of the paint solution is around 80%. And of course, there are technologies that can lift this up to maybe 85, 87%, but still there is always an overspray loss of minimum 15 to 20%. And if you talk about automotive industry, this is an example from automotive, and each car produces 3 to 5 kilos of paint sludge, which is a lot. So one car is being sprayed with the paint, and when that car moves along the production line, they leave behind 3 to 5 kilos of paint sludge, which has to be treated. And according to our estimates on the market, it costs around $300 to $500 per ton. That means per 1,000 kilos for treating that paint sludge. And in world, so total number of cars produced, this was data from 2022, 85 million cars are produced. So if you, let's say, take into consideration that you are producing around 3 to 5 kilos of paint sludge, that brings us to 340,000 tons of paint sludge worldwide. And that is a cost of $136 million that automotive manufacturers worldwide have to bear to treat just the paint sludge. So let's say Ford is producing 10% of the global cars demand. Ford is spending $13.6 million on treating this paint sludge, depending on how much the ratio is. So these are heavy costs that they have to concur while painting their cars. And we want to solve, or we want to reduce this cost as much as possible. I mean, you cannot bring it to zero. That's physically not possible. There will always be a little bit of overspray when it comes to robotic painting systems, but we can obviously reduce it. And that's where we provide components where we have already proof points. That means it is working in the industry since many, many decades. And we are keeping on upgrading our technology, let's say every couple of years, whenever there is a, let's say, demand to upgrade this. But we always start with proportional technologies, which is sort of a backbone for painting systems and robot systems that have paint applications. For these proportional technologies, the most important part is the fastest reaction time on airflow control for the shaping air of in and out. And this reaction time has to be as minimum as possible. That means if you are painting on surface A, your flow is X. And if you are painting on surface B, your flow is Y. So changing from flow X to Y, that time frame has to be the minimum that is possible. The second part is the sensors, our compressed air sensors, which are mounted on the air filtration unit. And of course, the flow and pressure sensors module, which give the data back to the robot systems, is a very important part of optimizing the performance. And the flow sensor integration is for closed loop feedback on all those flow and pressure changes that goes throughout the painting systems. And the third is the valve terminals. These valve terminals allow the compressed air flow through the robotic systems. and has to be very lightweight. Because they are installed inside the robot, they have to be very compact and very lightweight. And that's what we achieve with our AV03 valve terminals. And as I told, the backbone is the proportional technology for painting applications. And this is our, let's say, the signature product for paint application, which is called ED07 proportional valve. This is mainly double direct operating version. This has two solenoid coils on both sides, very dynamic flow control. This doesn't consume any air while operating. We have both EtherCAT and Profinet versions, which are standard in automotive industry. And it also has rotation speed control for turbines. So whenever there is a compressor going through the robotic parts, and on the front there is a turbine which rotates. So the speed of the turbine can also be controlled with this kind of proportional valves. And we also have feedback loop input directly on the proportional valves for the faster response. That means the signal can be provided from the valve directly to the valve islands or to the robot control systems. And because of this dual coil technology, it can have the fastest response time in the market. So standard flow control flow changes around 50 to 100 liters per minute. This kind of flow change can be realized within 80 milliseconds with the help of this valve. This is by far the fastest proportional valve. And it also has self-control adaptation. That means whenever you give an parameter input, it will adapt to the real flow rate versus input at flow rate without having to have the external parameters influence on it. It will have automatic control on adjusting to that flow rate within 2 iterations. And it is integratable directly on the robot arm. So we have many installations in many automotive industries, and this goes right inside the robotic body. And just to give an example of how fast this valve can be, so we have tested it multiple times, our customers have tested it, and this is one of the results which I want to highlight here. For example, from 350 liters to 400 liters per minute, this kind of flow rate change, it will take only 42 milliseconds to achieve this flow change without having to go on a huge fluctuation. So this is with hysteresis of less than, I think, 0.5%, which is also lowest for any proportional valves. And the time frame that we achieve these flow rate changes is absolutely what the industry requires. If we reduce this millisecond value as much as possible, that means it will have less overspray. It will have less time to change this. It will have less overspray into the air.
Let me ask you a question on this chart,
Yeah,
because this is very interesting. And we're looking at the step changes in the system here. And you can
yeah,
see those are lit up in red. I think part
yeah.
of this this chart may be in another language. Can you tell us what the blue and the green are? What are we looking there at?
The blue part is mainly the pressure. That
Okay.
is, let's say you are having a compressed air pressure of maybe 5-6 bar going through the system. So that's the
Okay.
value of the pressure going through it. And the green is the flow, the
Oh,
amount
okay.
of compressed air that is flowing through it. So maybe the amount is, let's say, 350 to 400 liters per minute. That is a change that we need. It's on this axis. And then blue is the pressure that we require to have this change.
And we can see, for instance, the step change from 250 to 400, 96 milliseconds, right? So that's a pretty
Correct.
big step change, and you can see it zoning in there right on the chart. You can see it
Correct.
really narrowing right in there, so that
Yeah.
on the blue line you get to your set point right away, and it looks
Correct.
like it's constantly adjusting to there for
Yeah.
the variables of the system. So as the system
Exactly.
is experiencing changes, it's locking right in there on that set point.
Correct. So the red line means this is the input given from the system, or the
Hmm.
robot is being already programmed. to
Hmm.
have this kind of flow change, because this is a graph. Let's say a Ford F-150 is going through a line, yeah,
Hmm.
and you have certain set of parameters already pre-programmed that how a robot should behave while painting a Ford F-150.
Sure.
And whenever let's say they are painting the hood of the F-150, and you need to change the flow rate from 250 to 400. So your set point always on each F-150 will be this 400.
Hmm.
And to achieve this, let's say flow rate here, it will take 96 milliseconds. Maybe sometimes it's slower, sometimes a bit higher. That's called hysteresis, and it will
Hmm.
be less than 1%. The values that you see green here up and down, that will be always plus minus 1%.
Hey guys, Shawn jumping back in here to let you know about one of the new services I'm offering from my new downtown office. In addition to custom in person training and virtual training, I'm also now offering one on one mentoring. This is a service that grew out of my online courses at theautomationschool.com, driven by students who completed my courses, were competent in their jobs, but then they'd run into difficult or confusing applications, and they wanted to hire me to sit with them virtually and review their projects, review their code, and ask questions. And I got to tell you, it's gone really well with the students I've done this with, and so now I'm releasing it to the public. If you want to know more, please use the contact link at either theautomationschool.com or theautomationblog.com. Now, another service I'm offering is the result of vendors and users coming to me and saying, Shawn, you got all that equipment in your studio. Could you test this for me? Or could you set up my computer and make sure it communicates to all those devices? And so I'm also offering PC configuration and application testing right here in my downtown office. So if you're interested in that, you can use the same two contact links to get in touch with me. And with that, that's all I have right now. Let's return to this week's episode of the Automation Podcast.
But it is still very exact, or let's say close to exact for this kind of flow rates and this kind of
Yeah,
pressure ranges.
fast too, very fast.
Very
Yeah.
fast, yeah. 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 Um, yeah. Apart from this, let's say another proof point that we try to give our customers is a dew point sensor, mainly because one of the important characteristics of paint spraying is controlling the humidity of the compressed air. Because whenever you are spraying a standard paint, be it in your home or even on the cars or wherever, if the air is too humid or too dry, that means when it mixes with the paint, it might deteriorate the quality of the paint that is being sprayed. So if the air is too humid, it might leave water droplets on your surfaces, which is, let's say, the quality might be rejected in the end. So you need to maintain your dew point based on the industry standards, be it in automotive or aerospace. Those dew point values are already always given. And we have integrated a dew point sensor, as you can see here, directly on the air filtration module. So before the compressed air, let's say monitoring begins, we already have a dew point sensor that gives the value via our dashboard from the software to the production guys, and they can see continuously how the dew point is being varied. And as soon as there is a change of, let's say, we can have an upper limit and lower limit, and whenever the dew point goes above and beyond those points, we can have a notification issued to the servers and they can react immediately. Also, we can have a module installed that might have impact on the robotic performance or robotic, let's say, movements that can stop for a while until the dew point is restored, because it's always easier to, let's say, have a quick stop for 2 minutes to check the filters and regulators before having to have rejected in the quality check because of the paint issues. So this is also a consolidated solution that we can offer our customers directly, also integrated beside the robot modules. And because of our experience into this application, we know what our customers want. We know how to solve those challenges. And based on those experiences and values determined from our customer experiences, we designed an integrated plug and play panel, which comprises of all the important components that integrator of paint robot might need to have the maximum performance of the paint application. That means they just can get with single part number the whole plug and play panel, which comprises of valve terminals, um, two proportional valves, ED07, which is mainly for flow control of the shaping air in and out, one more proportional valve for lower flow rate to control the speed of the turbines, and two flow sensors. So all this mounted on a panel, a metal panel, which has standard dimensions, which can fit into, I think, most of the robotic arms. Even if not, we can have extra cabinet just beside the robot to mount all these equipments. And the parameterization of the proportional valves are already been, let's say, programmed for paint application. That means integrators or even end users can just order this panel and have a plug and play solution ready to go for their paint applications. This makes it a little bit easier for the procurement guys as well.
Oh, yeah.
And last but not least, I want to show what's next. So as I told you, we keep on upgrading our technology to make, let's say, those applications much faster and maximize the throughput of the paint application as much as possible. And we are working on a new and compact design of our proportional valves because, of course, because of the dual coil technology, it's a little bit bigger than the standard proportional valves in the market. But we want to go ahead and have the next step with integrated sensors in the proportional valve body, which allows for maximum efficiency and lowest possible paint loss. That means these sensors are integrated into the subbase. As you can see here in the gray part, these are subbase attached to the ED07 proportional valve, which allows the flow of compressed air through it. And you can see one cable going through from the subbase to directly the proportional valve electronics. So that means we are shortening the distance of the feedback signals from the subbase to the proportional valves. So that means we will not need in the future two flow sensors that we had in the earlier panels. So this is a very compact design that we are working on. We already have prototypes. The results are also excellent on that. And the main technology behind this is newly developed Venturi nozzle sensors that we have implemented in this.
Will it
So
still
this
be
is
an
something.
Will it still be an ED07 when it comes out?
Correct. So it will be a special version, ED07 paint version, let's say. We'll have some special naming for that as well.
Okay.
So that's something we have been working on very successfully, and hopefully it will reach the market soon. And that's all from my side. I hope I was able to give you a little bit of insight on how Emerson can help solve customer challenges, mainly when it comes to paint applications.
Well, I thought that was very interesting. The intro, just seeing the breadth of products you have, a lot of those products I know discreetly from being separate and not part of the Emerson, the big Emerson line of automation. And then see the solutions you have for the robotic painting applications, especially with the dual coils down, the ED07. Very interesting, and the highest speed reaction too, to be able to make those step changes and get the flow right there within under 100 milliseconds, right? So, and that was a pretty large step change too, as far as the process was concerned. So, no, just very impressive. And we'd love to have you back in the future to talk about other topics. But for now, was there anything else you wanted to tell the audience before we close out the show?
No, I think we are pretty good on that. And as you told, like for the customers who are listening to this and interested into paint solutions, the main target, as we told, is to reduce the overspray and help you maximize the throughput of the robotic paint solution. And that's what we are here for. We have the experience of doing that. We know exactly what kind of components you will need, and we are here to make your life easier. So that's what this is all about.
Yeah, not only paint whatever you're painting, the truck or vehicle, whatever, faster, but then have less sludge afterwards to treat. It's a win-win because you save money on material, on treating, and your cycle times go up too. So win-win-win there.
Correct. Yes.
Well, Sumit, I really appreciate you coming on the show. I thought that was a very interesting topic, and just want to thank you again for coming on.
Thanks a lot, Shawn.
Well, I hope you enjoyed that episode. I want to thank Sumit from Emerson for coming on the show and not only bringing us up to speed on their discrete automation group, which I thought was very eye opening, but also to tell us about their new solutions when it comes to automated painting. So I thought that was very interesting as well. Now, if you enjoyed this episode, please give us a like, a sub, and a share. And please don't forget to visit our sponsor, theautomationschool.com. If you know anybody who's looking for PLC, HMI, or SCADA training, please ask them to visit theautomationschool.com. We have some new things going on. We have new Friday office hours where any student can join a Teams meeting from 9:30 to 10:30 a.m. Eastern and ask any questions they may have on the courses they're enrolled in. I'm also doing a live Q&A at 8:30 in the morning to talk about questions submitted by our Level 2 students and Level 2 members, as well as to kind of demo some application simulations and how to solve them. So with that said, I just want to wish you all an awesome week. I want to wish you good health and happiness. And until next time, my friends, peace.